Hello everyone, welcome. I'm going to help you out with this problem today. Our problem is a golf ball is dropped from rest from a height of 8.5 meters. It hits the pavement, then bounces back up, rising just 6.4 meters before falling back down again. A boy then catches the ball when it is 1.3 meters above the pavement. Ignoring air resistance, calculate the total amount of time that the ball is in the air from drop to catch. So, off of reading this, it gives us three pieces of information here. The height, the heights of where the ball will start and end. So this gives us three problems. I already have it laid out, 1, 2, 3, but just to visualize it a little bit better, we are going to draw it out. So it starts right here, 8.5 meters, comes down, it hits the pavement, and then it turns from rest, and then it comes back up, 6.4 meters, and then it drops down 1.3 meters above the pavement where the boy catches the ball. So here he's catching it, the ball's right there. This is 8.5 meters. I'll put little 8.5 meters. This is 6.4 meters. And then this is 6.4 minus our 1.3 because 1.3 is the where the ball ends or where the boy catches the ball. So 6.4 minus 1.3 gives us 5.1. So this is 5.1 meters. So now that we have a decent visual and you could draw it out, it's a little bit hard to see with this marker, but we can now start. And this is going to be separated into three parts. You can see I have it labeled here. This is 1, 2, and 3. So we want to know how long the ball is in the air, which means we have to find the time that the ball is traveling. So we're going to have to find for all three parts using all these different heights. So right off the bat, we know that our height, or our delta y, is 8.5. We'll go ahead and start with 1, and we have y is equal to 8.5. Hopefully you can kind of see that. Next, we know that our acceleration, since the ball is going down, is negative 9.8 meters per second squared. Right now, the last thing that we know is that the ending velocity will be 0 because as it hits the ground, it's going to turn and come back up, and it has to have 0, has to equal 0 before it can go back up. So our ending velocity is 0. So after looking at all of this, we can use our kinematic equations. Now, I'm using y instead of x on here because x is going this way, and obviously the ball is bouncing, so it's going in the y direction. So we can substitute x for y here. Looking at this, we can kind of figure out which equation we want to use. And when you look at this, we can use kinematic equation number 3. So I'll erase all of this since we already know and we have it visualized. We'll use kinematic equation 3. Delta y is equal to v naught t plus 1/2 acceleration t. So the good thing about this is we know that v naught, right? We also know v naught is starting from rest. Because, well, it says it right there. So v naught is starting from rest, so if we were to multiply this, this would cancel out, just giving us y is equal to 1/2 acceleration times c. So we really don't have to worry about it, which is a really nice thing. So moving forward, we're going to isolate the t, and that will leave us with, oh, this is t squared, by the way, I can't forget that, t squared. This will leave us with t is equal to the square root of 2y divided by a. And now we just plug everything in and then solve for that. So if we were to plug everything in from 1, we would have t is equal to the square root of 2 times 8.5, all divided by negative 9.8. And this, when we put it in our calculator, I have it right here, will equal, I guess I'll just do it right here. T will equal 1.32 seconds. And now we have to find t again. And since the only thing that's changing is our y value, we can just use this same equation down here. So we'll go ahead and input it. T is equal to the square root, and this time y is equal to 6.4. So t is equal to 2 times 6.4, all divided by negative 9.8. And all of this is within that square root, and this should give us 1.14 seconds. And then for the last one, our y value is equal to 6.4 minus 1.3, and that is 5.1, I think we said. 5.1 meters. So put that in again. T is equal to the square root of 2 times 5.1 divided by negative 9.8. And this will give us 1.02 seconds. So now we found the time. Now we found all the times for all 3 different parts. All we have to do now is add them. So we found them, and now let's go ahead and add them. So I'll turn the board this way. 1.02 plus 1.14 plus 1.32 is equal to time. When we add all of that up, we get 3.48 seconds is equal to our time. So our answer for the amount of time that the ball is in the air is 3.48 seconds. So I hope this helped, and I hope it made sense. If you do have any questions, please leave a comment. But if this did help, please like the video so other students know that they can come to this video and it can help them out, and we can help more students out. So thank you, and I hope this helped.